Alright guys, so around 2 years ago we did something on the YouTube for detecting flood damages in Sindh province for Pakistan, and for this year duration 2022. Now the basically we use Sentinel-1 radar images, which is really powerful, but has a lot of noise. So in order to remove those noise we had to use this Refined Lee filter, and then we used this filter could only be applied to the natural units, since we had the decibel units in order to consider it for visualization and brightness compare. um, but we have to convert it to natural units, apply that filter, and then convert it back to decibel units to display the visualization. Now, it was great, but the problem is we have been using this Mosaic lost the details of the time, and also we had a very simple threshold, um, this for detecting floods. Now, the problem on in this is this leads to the existing water bodies identify into floods. So basically, the flood actually never actually occurred here in this portion, but because there is a percentage of water bodies detected under this filter, so it identified as a flood. Now we're going to update this logic to a more precise one, and I will guide you through how we have approached it. All right, so for here we have the updated code. So let's go through each step by step. I've divided it into the step, and then we'll go through what changes we got in the result and what changes are here in the code as compared to the previous. All right, so step one is basically we're doing nothing change. We are actually importing the overall boundary of Pakistan. So all the provinces are present in this feature boundary. If we go into this, that's the all details and the province's name. So we're for now we'll take Sindh since we are comparing like from the previous script, and then we're gonna add a layer of this Sindh boundary onto the map. So this is Sindh boundary. If we can go and see, Sindh boundary has been selected. As you can see, this is a white saddle layer on the map because I've chosen white color. You can give no color as well, and then it will give a grayscale color. For satellite imagery, we are using the Sentinel-1 SAR data. This is a radar imagery captured by the European Space Agency satellites. So unlike the normal optical images, radar can see through the clouds day or night. Just you need to know this. That is so important in flood mapping. And previously we have been using VH, which is basically more sensitive to surfaces, roughness and water, but now we are actually including another field called IW mode, which is radar's main mode for land monitoring. And then we are getting all of that in the ascending and descending orbits. So basically we capture full coverage of Sindh. That will give us the clean and filtered image collection ready for analysis. On step 2 we do nothing, we just define the time periods. We divide the radar data we got above into three time ranges. So the flood actually occurred from June to September. So once you have identified that, the previous couple months will be the pre-flood for a normal condition in which we just compare the dry land condition, and uh, post flood, which is a new field which we have added, which was not present in the previous script. So we basically try to monitor when the water is receding or where the water is still present even after the flood is gone. You can just print these in order to know that the data is coming, so the filter are applying correctly. Now step 3 and 4, step 3 basically is nothing, just a couple functions. So these two functions I've taken from the previous script. As I described earlier, we need decibels to visualization and comparison, but we need the natural units to apply the filter. So we will be applying Refined Lee filter again, because again we've got the SAR1 data and it's very noisy. So the Refined Lee will help remove those noise. So this function All these three function, I will put this in the comment. You can just straight away get this. It's a very complex function in which we have created different filters. So if you don't know regarding the digital image processing, let's not deep dive into it. This video for a later. For step 4, basically, we are creating filter composites. Now what is that? Basically, in order to first tell on that refined Lee filter, what does it do? It basically just what the noise is. If it is written the speckle effect filter, speckle is basically the salt and pepper noise. Salt and pepper noise are just the small particles that usually you can see when you capture a image from a old phone, smartphone camera. Those are salt and pepper noise, which is not a real texture, it's a random interference. What refined leaf filter does, it basically it smooths out those random variations while keeping the edges and fine details intact. That's the most important things. And then we are going to convert it back to decibel, right? All right, so for step 4, as we were discussing, now we take the median. As you can see, we are using the median of all the images in each time period. So pre-flood, flood, and post-flood, we use that, and we take median of those, and then we apply a filter and clip everything to Sindh boundary. um, this will again give a clear snapshots of one before, one during, and one after the floods. And then we are actually adding a layer as well of this. So it's a pre-flood, post flood, and we're not actually doing the post-flood here. And then for the step 5 is basically where the real analysis happens. So just 2 lines of code are the actual analysis. So we look at the radar brightness in the VH band, and water appears dark. It reflects the radar waves away instead of back to the satellite. So let me just clarify it is how the threshold we are defining. So anything below minus 20 decibel is likely water. All right, so we are just comparing it like this. And the areas that were bright before, which means those areas that were dry lands but became dark during the floods, which means that there is a new addition of the water. So that is we are identifying as a flood water. So the area that stayed dark before and after the permanent water bodies, these are lakes and rivers, right? So let me just clarify this, that areas that were dark before and also after, right? So which means there were water present in them already. So that could be the water bodies like lakes and river where the water is usually present. Step number 6 is nothing, just the visualization. We're just creating 2 masks, permanent water, which we give blue color, and flooded areas, which we give red color. So when we add that onto the map, that's how it's going to be looking. Now if we run the whole code, which I've already ran, let us just apply it. So this is the pre-flood. It's nothing, again, as we discussed, it's the light and dark color comparison, where the light color is, where the dark color is. Dark colors are more of a water body, like as you can see, this is a really dark area, and if I cut it out, you can see this is already a water body. This is already a water body. All right, so let's just apply the flood filter then. The flood filter is now comparing those dark areas with the grayish areas. So now this is the only flood filter which we are giving. And now let us add the permanent water and flooded areas. So this is now the permanent water which we have given the blue color. And what about the flooded areas? The flooded just load, and this is actual the flooded areas, where the areas that have been affected deeply by the flood. All right, so again the permanent water and then the flooded areas. You'll zoom out, it has to reload again, so just wait a minute. And now let's just compare it with the previous one. So in this previous, we had the same filter and same everything, but our threshold and our analysis were totally different. So what actually was happening, it was identifying this whole trail as something, as it it was affected through the flood, but that's not the case. The flooded affected areas were majorly these areas. Obviously there is a sparkle of red in here as well, so obviously there were present impacts in here, but the fact that we can more go zoom into it and we can see more details, it has to reload again. But the fact that we are now identifying the pinpoints of the actual areas that were affected by the flood, so instead of just a complete overall just a boundary that this was all affected by the flood, this is a much more deep analysis. So it's a hybrid approach between the new approach and this one. So hopefully you guys have liked it. Let me know in the comments if you have any issues. It's a very simple code. We're basically using just a complex thing of these three functions, otherwise we're just setting our own thresholds. So right guys, that's all pretty much it. Let me know if you have any issues in the comments, and I will catch you in the next one.